So who here is a PHP developer? Okay, all right. Anybody here not a PHP developer? You're from the JavaScript side of the conference, but you snuck in? Okay. Would you admit it if you did? No? Okay. So we're all PHP developers. Anybody here not a developer, does something else, systems work or something else? Okay, good. All right. Not that I mind, just I know who everybody is. They're all PHP developers. How many people here have played around with Go already? Okay. How many people have not touched it ever? Okay. All right. Is anybody here just to heckle the Google guy? No? Okay. Would you admit that if you did? No? Okay. Yes? Okay, good. All right. That gives me a good grounding. I'm Terry Ryan. I'm a developer advocate for Google Cloud, which means I go around. I spend half my time developing on top of Google Cloud, just like a customer with a really, really good NDA. And the other half of the time I spend going out talking about what Google Cloud can do. I don't think this Prezzo has a lot of specific to Google Cloud stuff in it, but if I did, and I'm not remembering it, everything you could do on AWS or Azure or anything else, but I don't think I get into that too much. Another thing I want to make sure I make clear is Go is just another tool. This is something that worries me giving this type of talk, where you're saying hey, you developed one thing, you should try this other thing, right? And it sometimes comes off as give up what you're doing and do this new thing. I don't want to make that. I don't want to make that impression. Go is a tool. PHP are tools. These are tools we use in our development life. I hopefully am giving you just another tool that you can use. So, introduction. What is Go? So, Go is a programming language, right? It was developed at Google. It's open source. It's compiled. And at some point, when you start exploring Go, you ask yourself, what the hell is this thing? It comes up in all the documentation. Go has a mascot. The community is very weirdly attached to it. So you will see it everywhere. And it's a little creepy. So that's okay. It's normal. They do that. If you want to find out more about it, it has its own page on the Go website. Like I said, they take it very, very seriously. All right. So what is Go? We said Go is a programming language. It's open source. It was started at Google. It is now sort of not run by Google itself anymore. It has its own steering committee that takes care of it. It is compiled, in contrast to PHP. It is garbage collected, so you don't have to worry about memory allocation or any of that stuff. It is strongly typed and statically typed, meaning every variable has a type. You have to declare it outright from the get-go. And once you declare a type, you cannot change that variable to another type. You can convert to a new variable of a different type, but once a variable is set, it is set. The syntax is C-ish. I think it has its own syntax that's sort of C, but we'll see about that. It is very, very simple. And that's not necessarily a brag. That's just a statement of there aren't usually 10 different ways to get something done. There's usually just one way of doing it that may or may not be good for you. It's built to use multiple processors, so it kind of has an awareness of multi-processor architectures from the get-go. So spinning off concurrent processes are pretty easy. Tools are already designed to deal with the fact that, yes, we're going to be pulling down packages from the internet to run our stuff. And the language has tools built in to make that a little bit easier. Testing is built in, and it's a language focused on software engineering. And this is where I feel like there's a big win to kind of join up with PHP developers, because a lot of the other languages that are sort of still up and coming right now, like Erlang and Rust and you name them, they tend to be academic. They tend to be like, we have this concept and we want to pursue this concept. Go is about getting stuff done, and I feel a lot of kinship there with PHP developers. Like we don't care that academics may not look kindly on the language. It gets stuff done. I can get stuff done really quickly in it, and Go has that same property. So we're going to start. We're going to write a simple CLI. I'm going to jump back and forth. Sometimes I'm just going to show the code. Sometimes I'm going to show the code and run it from my IDE. So let's just see some code already. So let's write our first Go program. This is the structure. I have a file named main go. It is package main, and I have a function in it called main. This is pretty standard. If you want to create a Go binary, this will be the the main source, the main starting point for the binary. So even if I add packages, even if I write sub packages, I'm going to have to start with a main name. You don't necessarily have to name it main Go, but that's sort of stylistically what they do. This is hello world, right? I'm just doing print line hello world. This isn't actually how you would do it in Go. I just wanted to write the simplest version of it. Because what you would do in Go is you would actually use the standard library. Use the thumped, and yes, they call it thumped. The thumped package, which has all of the string, all the I/O, writing to strings and handling that features. You'll notice that I have to import it. Even if it's in the standard library, I have to pretty much import everything. The one exception being that print line that is there for those in the last slide. That's there for it's basically there for debugging without having to import thumped. But this is how I do hello world, var string hello world, thumped print, and then I'd call the string and do it that way. So let's just show that real quick, show that I've got nothing up my sleeve and this stuff all really works. Let's see here. Let's close this down because I'm going to get back to it later. All right, and hello world 2. There we go. All right, is this big enough, or do I need to bump up the font a little bit? Oh, the lighting is rough. Let me see. Hold on. References, color theme. Is that better? Okay. All right. I'm going to bump it up one more time, and then we'll run. So to run this, I'm just going to go main go. Sorry. Go run main.go. Hello world. Shocking. So that's simple Go. All right, now let's go further. Let's go in here. All right, so that's how I call it. Now, I wrote the string like this, var s string equals hello world, but that's not actually how you do it in Go. I just sort of wanted to make it very clear what I was doing before I explained this. In Go, you use type inference a lot when you're setting straight variables like this. So I would actually just say s colon equals hello world. Go will initialize the variable and assume that it's a string because that's what you're passing in. So this is actually how I would write that, and just a little bit different. Okay. So types, standard types are pretty prevalent. Bools, strings, a whole bunch of ints. Bytes, runes, floats, complex, and I'll talk about arrays, slices, and maps now. So you're used to dealing with arrays, and in every other language you call it an array, but you very rarely deal with straight arrays in Go. Reason why is because an array in Go is a finite order of collected elements. So I say users equals 4 strings, and I have 4 strings saved there. If I want to do something dynamic, I use a slice, which points to an array, but you ever actually see the array implementation underneath it. And I would say users equals a slice of strings. Why? So let's go, here's, I set an array of greetings, right? Because we're doing hello world. We're going to do hello world in multiple languages. I say greetings equals an array of 5 strings, and here they are. Well, if I add to it, it'd be an array of 6 strings, but since we're statically typed, we can't change. So I can never change or add anything to this array because it is an array of 5. I could sub in, I could swap elements, I could replace hello world with the Korean if I wanted to, but I couldn't add Korean. So what I would do is instead create a slice of strings, and then I can append. Greetings append, and I can add, I guess that's Greek I'm adding to it. So when in doubt, just use a slice. I never actually, like the number of times I've ever actually used what is a Go array is like, I almost always use slices. But you go and look up this stuff up, and the kind of documentation assumes you know that distinction, that you know that slices are what you want, and arrays are not what you want. So just a little gotcha there. Okay. So I now have a slice of strings that I'm going to use to power this app. And now I can do something like this, where I say, here's my, I just abbreviated it, but assume that it's all the strings. I'm going to randomly seed. Whenever you call the random function, you have to seed it. So I'm going to seed it with time, now, Unix, nano. This is good for this type of application, but not good enough for like cryptography, so just be aware of that. Take the length of the greeting array, and then I'm going to get a random value for this, and I'm going to plug it in here, and this is how I refer to that. Okay? So we now switch back. Well, let's see, what is that? Is that main 3? Yep. So here's that same function. I'm going to run that. Go run main.go. Okay, and I get the Spanish or Portuguese, China, Korean, Greek. All right, so it's working as expected, although I'm worried that there we go. All right. Oh, hey, spin out the German. Great. All right, so now it'd be nice to have input, right? We want to actually, interact with our app here. So this would be the format I'd like to do. We'll just start with getting one of the values of that array instead of getting a random value. And what I'll do is I'll use a flag. So I'll say flag int, I'll parse the flags, and then I'll use the flag here. Now let's break this up, explain it. So flag int lang, which is the string I'm going to use on the command line, a default value, and a definition. Which I can use to get help from my executables later if I want. I parse the flags, and then I'm going to use star I. What is the star? Star means that I get a pointer and not the actual value. Pointer is a link to the memory address of the value. It allows us to pass by reference instead of passing by value, basically. In dealing with them, you will see stars and you'll see ampersands. I could talk about this for a very long time, but I'll give just sort of a quick, if you just see P, person equals Steve 28, P is a person. That's just a person. If you see the ampersand here, it means that you're creating a reference to a person and not the actual, it's not the actual values, it's the reference you're going to be passing around. And then if I want to get that value out, I use the star to get it out. That's going to give me the actual value. If I pass in the ampersand, that's going to pass me the reference. And then my functions can require either the value or the reference. You will see this a lot, so just be aware of it when you start using this. That you need to pass around the references for a lot of the standard library, especially for things where you're mutating the value. You're going to want to pass a pointer instead of passing the value. All right, then we're going to handle errors. We're going to make sure that if someone passes in a value that is not in the array, that we throw an error message. Now, this is one of those places where I point out that Go is simple. In a lot of languages, you can create some sort of thing that kind of is between these two values for shorthand. You cannot in Go. Why? Because this expresses it simply, and well, I assume, right? That's what the authors were trying to do. They don't want to. They just want to make it simple and brute force. This works. Everybody will understand it. There you go. All right. So I'm going to run this and make sure that again, nothing up my sleeve. There we go. And main. Go run main.go lang equal 4. Hello world. Yep. All right, I got it. And then 1, then 2. All right. So this is all working. And then if I pass in a value that is completely wrong, I get the error message out. Great. So everything's working the way we expect it to. Okay. So let's finish up this program. It would be nice to actually, if this was the interface, right, where I pass in the language that I want. So what I'm going to do is do a map, which you might recognize as a hash or just an associative array in PHP, but it's called a map in Go. And to be very exact, you have to initialize it with this format, the key value and the value, the key type and the value type. So I can do it one of two ways. I can do it literally, or I can make it, it'll make an uninitialized or initialized value of it, and then I can use that later and populate it dynamically. So then this becomes really simple. I have a map. I take in the format from the flag, and then I check to see if it's in the map, and then print it out. At which point, someone might say, what the hell is that thing? You will see a lot of Go code that looks like this, and when you're first getting into it, it will confuse the hell out of you, or at least it did me. If it didn't, great. Doesn't confuse you, great, but it did confuse me when I first got to it. So let's break this down. If I was doing this in PHP, do pretty straightforward. I have an array of greetings. I just type them in like that. I check to see if the value is already set in argv. If it isn't, I set it to English, because I prefer English, sorry. You could set it to German, it'd be fine. Then I check to see if it exists in the array, and if it does, I print out the value. If it doesn't, I send out an error message. Okay, pretty straightforward, pretty simple. All right, so let's now switch back to this construct. This is exactly what we're doing here. We're checking to see if it exists in the array, and if it does, it's going to spit out the message, and if it doesn't, it's going to spit out an error. So if r OK equals G flag L, or sorry, pointer L, OK, printf. All right, so let's break this out. Let's separate this out first. Okay, so we split out the if, which makes a little bit more sense, but let's make the variables like human readable. And we get this, result key exists equals greetings language. Go can return more than one result from a function. You can return, 2 is the most common, but you could return any number that you want. So when we do this operation, when we try to get the key of a map out, it returns two variables, a result and does the key exist. So if the key exists, we want to print the result. If the key doesn't exist, we're gonna send this error message. But all of the variables here that aren't from above and that aren't greeting and language, result key exists, only really get called here. So Go prefers, if you're only going to call it if you're only going to use it once, to keep it in the most limited scope you possibly can. So if we do that, we can put if result key exists, greeting language, and then key exists, then print out the result. And then result and key exists only exist in this one little box, and then after this, those variables go away. And so that's a little bit more efficient. And then finally, Go prefers small variable names. So you would write it like this, r equals OK, OK, and that. So we go back here, and now this makes a little bit more sense. This may bring up the question, why are Go variables so short? And you will see this all the time when you read source code. Go read any of the standard libraries. The variable names are like, it's almost like Go is like, could we be like less scrutable than Perl? Could we do that? And the reason why is because Go creators of Go, we hate you and we hate things that are good. That is the joke I make at their expense. What they would actually tell you is that variable names in Go should be short rather than long. This is especially true for local variables with limited scope. So in that case, result and key exist. They're only used in that one space. It makes sense. We don't need to scan over the whole document to see where they are. They're only used at one spot. We can make them one character, and that's all that matters. So prefer C to line count, prefer I to slice index. And the joke I like to make is that PHP would call this a dog. Go would call this D, right? And of course, we can all laugh at our friends in the Java community because they would call it puppy with a sad face factory bean, right? So I kind of happier to go the really, really short way, right? Actually, I could make the joke that it'd be another type of factory, the dog, but I don't want to be too scatological. So as short as we can while being descriptive, and the further away from which they're being used, the longer they can be. So if you have a variable that is used throughout your entire routine or your entire package, it's a global variable. Yeah, you're going to want to be long, so it's descriptive. But if it's short and it's really used in one place, R, right? So the local variable is R, a package public variable would be rate, right? So some variable name conventions, too, this helps out. I is usually index, C is count or context, depending on the context. R and W are reader writer, requester response for HTTP requests, error is error, buff is buffer, F is file, and OK is for any one of those times you do an assertion as something exists. OK is kind of what you'll see in the code. All right, so we have our CLI. We're able to do more operations with it. I'm not going to bother running it. Let's now talk about packaging or writing code to be shared. So this is that same function packaged up so I could use it in multiple other places. So in this case, I have package hello world because I'm defining it off. It's got to be in its own folder called hello world. var greetings, I have that defined, and then I don't have to worry about flags. And I just say greet language, and you see this is a long variable name. I actually got the note that, does it really need to be language? Could it just be lang? Could it be shorter? And I decided I'll be, for the purpose of this, be a little bit longer and less inscrutable. So it takes a language, which is a string, and it's going to return a string and an error. Like I said, this is actually a very, very common pattern. Result and error. So if R is OK, return the result and nil for an empty error, else return an empty string, and errors.new, the language you selected, is not valid. Now, this actually isn't how I would do this. Just kind of wanted to start here. What I would actually, no, I'll get to that in a second. Never mind. That is how we do stuff. Don't ignore the man behind the curtain. So in my packages, if I want it to be a local function, the first letter is lowercase. If I want it to be public, the first letter is uppercase. And that's all there is to it. One is private or exported, or unexported, and the other one is exported. So going back to this, there we go. Going back to this example, greet would be accessible outside the package. Helper would only work inside the package. Okay. So now we get to error handling. So I had this is the function, right? And I return errors new, the language you selected is not valid. What I would actually do is I would create a exported variable, error not found, and I would call it errors new, the language you selected is not valued, and then I would pass this error out. And I'll show you why in a second. So in my calling code, the way I handle this is I call the greet function, and then if error is not nil, log fatal error, like the text of the error. But in this particular function, I have the list somewhere. I could return the list if I wanted to. So what I can do is say, if error hello world error not found because it's exported, so are these two values the same? If they are, just list the languages. If not, then throw an error. And otherwise, if it works, just return the greeting. So you'll see this a lot when you start handling errors. You will compare errors, and it's really great when you have defined error types. It makes this sort of negotiation a lot easier. So, okay, so here is my hello world package all kind of set up. So when I want to call this package, I am sharing it on my GitHub repo under Go samples and hello world. So anyone else wants to use this, this is what they would refer to. And I'll show you how to pull down these dependencies in a second. But this makes it really clear when you're reading the code, if you want to look what is this package that he's calling. If they're up here and they don't have any prefixes, we know they're standard library. If they're down here, and the formatting tools you use for Go will split these up for you. But if not, you have to do this. You have to split them up like this just for readability's sake. And then I know where that is now. All right, let's talk about object orientation. Because Go is not really object-oriented, but you can sort of pull it off. You can do what we call custom types, which are mostly around structs, but you can do anything as a custom type. But most custom types are going to be strings, going to be structs. So instead of passing out just a string of greeting, I want to pass out a structure. That structure has text string. And then I can add methods to that custom type. So I add a receiver here saying greeting. So whatever the greeting has been set, if someone asks for the address, it's going to return gtext plus human. So I say hello, it's going to say hello human, right? Then if I want them to be private, because we don't want our threats to bubble out of this custom type. We have our threat, so only another method in here can call that, and human, we will crush them. And then if I want to have a unexported variable, I can do that too. So this secret is part of the structure, but it's only callable, only interactable from inside the structure itself. So package type and method names. Be descriptive but concise. So package L, a little bit too short. Package log file writer, a little bit too long. The sweet spot we're looking for is log, right? And then don't repeat yourself in the method name. So no log file write, or log file read. Better yet would be log write that takes a file, log read that takes a file. But even better than that, and I won't go too much into interfaces, but just interfaces are a thing in Go. I could write to an interface. So log write destination IO writer, log read source IO reader. What this allows me to do is, especially for testing, like a web request, right? I don't want to actually spin up a browser and do my tests in a browser. I want to just have the test all work command line. So what you can do is simulate a web browser, because all of the methods around the web require a type, not necessarily, require an interface, and not necessarily it has to be an HTTP request. It can be any reader or any writer. So that helps. All right. Speaking of the web, we didn't come here to build CLIs. We came here to build web applications. So let's do that. So we have our web app, and we have our base package that we talked about before. Package hello world, we have our greetings, we have our error that we're exporting, we have our greet function, which returns a string and an error, and then we have our languages function that just returns the array of greetings. I made this private and this call it, because I don't want someone outside the package manipulating the greetings. Then we have our web function. We see we have a bunch of new imports. We have log encoding JSON and net HTTP. Then we have our hello world package. Then we have this. I'll talk about that. So basically, with Go, for the most part, we don't use outside browsers, because HTTP serving is all built into Go. I'm sorry, not outside browsers. I meant outside web servers, right? So you can hook this up to Nginx, and that is in some use cases pretty common. But even more common than that is to just expose build the web server into the Go executable and expose the web executable. And I often get the question well, is that safe? Can you really spin just your language directly out? And the answer is we do it at Google all the time, so we're okay with it. So we've been doing it just fine, but some people do put a reverse proxy in front of it, and that's totally fine. So I handle function. I say I want all requests to get handled by handle get. I want all requests by list handled by handle list. And then I want you to listen and serve on port 8080. So handle list is pretty similar. It's pretty basic. I get the list from hello world languages. I convert it to JSON. I then take that, and if there's an error, I spit out the error. And if not, I send out the JSON with HTTP status OK. And I'll show that function in a second. Hello get, little bit more there. I get the form value. So I want the query string for language from the URL. I want greet. I do that function. If they ask for something I don't have, I return just the error. I didn't bother with error checking, or checking if it's not found. And then send the JSON. And then handle error is pretty straightforward. I convert it to a string. I convert it to JSON, and then I send it to using send JSON, and then log the error. Otherwise, send JSON will set the header, write the status. In that case, before it was HTTP OK. This time, it's status internal server error. It'll write that and then print out the content to the response writer. So hold on. We'll see that in action before I get to concurrency. Let me. Is 9 the right one? Nope. That's concurrency. There we go. So here we are. We're running this. We'll go go run main.go, and we'll allow outside function calls, and then this should throw a 404, which is fine. because we actually want that. So if we list, we get that. If we go to get and we put nothing in, we get the language is invalid. And if we put in, why am I asking for French? I ask for German, hello Welt. And we look back here on the command line, we'll see that the error bubbled up into standard out. It could also get sent to the logs, but then we kind of know what's going on when that happens. So simple web server written in Go, and that was all it took. Okay, so one of the big features of Go that we talk about a lot is concurrency, and I want to show off concurrency. I don't have any slides on it. I'm just going to show kind of pure code. So I have a couple functions here, greet Munich, greet Paris, greet Cairo, Beijing, whatnot. If we look at what I have here, I have some constants, which are the distance I am from each of these places. These are approximate in kilometers from each one of these places. And we're in Munich, so it makes sense that it would start from Munich. So when I greet, let's look down and see what the greet functions do. In each city, this is just a way of tracing how long it takes, because we'll see that in a minute. Then we're going to sleep in milliseconds the distance from the city in kilometers, and then afterwards we're going to send a greeting. And we'll pass in German, so we spend in the right language, and you'll see all that does is call hello world greet language, and then print out, ignore the color stuff, it's just changing the formatting when it comes out. In Munich, which is 0 kilometers away, they say hello Welt, right? I get it right? And that's it. You'll notice here, I don't really care about the error, not because you shouldn't care about errors, but I just want to make it a little bit simpler. And when I don't care about the variable, I set it to this underscore. The reason why is if I let this be error, that would be a variable that I initialize, then don't use, and Go will throw a compilation error. So if you spin up a variable, you have to use it. If you include a package, you have to use it. Otherwise, Go will send a compilation error. All right, so we know what this function is going to do. It's going to greet from all of these places, and it's going to basically take as much time as it is far away. So let's go run main.go. All right, we kind of see it happens immediately from Munich, takes longer from Paris, takes still longer from Cairo, and it's going to keep going as we go through. This is suboptimal, right? Like, it shouldn't take n plus n plus n plus n. It should take the longest time of the last greeting, right? It should be Mexico City, I believe, is what'll be the furthest away. So this whole thing, which should have taken 9.845 seconds, took 30 seconds because we added all these up. If we could do them all at the same time, we'd get a better result. So we're going to do that. So we're going to comment out this, and we're going to add concurrency. Go concurrency is actually really straightforward and simple to start with. Then it gets really confusing. So hopefully I won't get you there. Let me comment this out. All right. I'm going to cheat. There we go. Come on. There we go. All right. So to run in a separate, not in a separate process, but in what we call a Go routine, which is much lighter weight than a thread in, say, Java, I just put Go in front of it. So it creates its own subroutine. Go greet Munich, go greet Paris, go greet Cairo. And these will all run separately, and I don't have to wait on each one. They'll all run at the same time. So let's do that again. And oh, wow, we actually got Munich in before it stopped. Why? Well, because it's going to fire off each one of these. And in this case, let me clear that so it's less confusing. Try it again. It was able to get to Munich, but by the time it called the rest of them, it was done, so it closed down the whole function. So in this case, I can't just fire and forget because the app isn't still running. Now, if I was running something like a web server, I could probably do it because the whole process is still going to keep running. But in this case, what I'm just going to do to make this kind of the simplest is I'm going to sleep for 12 seconds. And if I sleep for 12 seconds, we should see the function stays running and all of these happen, and they happen instead of additively, they happen sequentially instead of sequentially, they're happening in parallel. So the whole thing took 12 seconds, which is good, but still suboptimal because I had to like sleep for some arbitrary amount of time. What would be better is if I could wait for things to get done. So I'm going to go to that version of it, which again gets a little bit more complicated. So I'll walk through this code. Back and clear. All right. So what I'm doing here is I create a sync wait group, and I add 6 to it because that's the number of functions I'm going to call. You can do this dynamically if you want, and I do in a lot of cases. And then I wrap an anonymous function here. This is go function greet Munich, and then also say WD done. So there's 6 of them. When they get done firing, they're going to say done, and then the counter is going to slowly go down on this. At the very end of this, I say wait. It's going to wait till all of them are done. So now, when I run this function, clear again, and then go run make go, it's going to run again in parallel. Great. We're going to take a little bit longer for the rest of it to come because it's further away. But then San Francisco, Mexico City, and then done. Nope, because I didn't actually save. Sorry about that. So let me try that one more time with actually saving it. And you'll see what will happen. In this case, it'll go all the way to the end and then end right after Mexico City instead of having to wait another 3 seconds. There you go. Worked. All right. So that is concurrency in Go. Really simple to get started with. Can get very confusing the further out you go. So let's talk a little bit about tooling. Go, if you contribute to any Go open source, you have to format it the right way. There is no, though, do we put it on another line? Do we put spaces? There is no that discussion in Go. There is one way to do it. You run go funct, and it'll take care of that for you. Like no extra lines. Like if you like, I'm going to leave a whole bunch of space here because I want to write a function there eventually. Go will just go nope. That's just, again, it's stylistic. There's only one way of doing it that has its pluses and minuses. If I want to build the executable, I just say go build, and that'll build the executable of this version. I don't have to run it every single time. Testing, go test. I'm going to really quickly go through testing scenario here. So in my hello world package, I have hello world _ test. And you'll see that up at the top, it's just part of package hello world. So this is what we call a white box test because it can see everything that's in the package. So it can call internal variables and it can cause more harm or do more good depending on your outlook. So I have my test here. So I'm going to go ahead and run this. And so I'm just going to say go test. And you'll see that it passes. Now, one of the cool things that's built into the testing tool is coverage. It's built right in. And I can see that I'm only at 57% of my statements are covered. And that's because I'm hiding all of this up here, commented it out. So let's go ahead and uncomment this. And when I do that, and this is one of the, I'm going to go to the slide just because I can show it all on one screen. So let me make it bigger. Sorry about that. So a very common pattern we see in Go testing is you build a table of tests. So you build cases. I have my input, I have what I expect out, and I have an error. So in the case of I put in nothing, I should get back nothing and error not found. If I put in English, I should get back hello world. And then I do a range over those. And the range format goes for index, value, range classes. So I don't care about the index. I only want the value. So I go actual out, error out equals this. And then if actual out does not equal out, I'm going to throw an error. And if actual error doesn't, I actually can ignore this part. I didn't realize that when I wrote this slide. But I actually just say if actual error is the same as C error, then throw this test result. So when I call this code, we'll go ahead and run it. we'll see that there are 2 failing tests here. You need to write this kind of like so we can see what the input and what the output was. But if you do that, I can see, oh, I have some extra statements here for English that I don't really need. I'll comment that out. And then when I go here, I'll go test cover, and we'll see I'm at 85%, but it's all passing. But what is that last 15%? And again, this isn't, you should, for something this small, it's not that big a deal. You shouldn't necessarily have to pursue 100% coverage, but like I'm going to be a stickler. I'm going to say it's got to be 100% covered. One of the ways that I can do this, I can see what's going on, is you'll notice that I have, if I run this test here, run package tests, it runs, if I run it in the IDE, I get the coverage, and then I can actually see here, oh, all right, so that green is all stuff that was handled by the test. Red is stuff that was not. I'm not testing whether or not the error returned. So let me go back and do that. And now when I run this package, I get 100% coverage. And I go back here, and you'll see that line is lit up. So all this tooling is integrated, and it's all part of the Go pack. Like you get it right from downloading Go in the first place. So really, really helps make testing and all that faster. Documentation, if I want to see the documentation of the package, I can type go doc. If I want to see it in a way that's actually meaningful and helpful, I type go doc HTTP. They are different. One is go space doc, and one is go doc, one word. HTTP 8080. And then assuming I write all of my comments properly, and there's a style guide to writing that, and most of the Go linting tools will catch if you don't follow it. You will get this out. When you start looking through Go documentation, you will see this type of screen, this exact look and feel all over the place, because it's the only thing people use for documentation is your package documentation. You can add examples and you can add other stuff to it to make it work. And in fact, the way you add examples is you add it to your test case, and it'll actually test the example code for you, so that if you write example code that doesn't work, it'll get flagged by your tests. So all of it, you can be sure that all of your examples and everything work before it gets into documentation. So if I want to retrieve a dependency, I say go get github.com/gorilla/RPC. That'll get that package down and pull it down. So that's how I retrieve dependencies as I'm building as I kind of figure out that I need other packages to do stuff. IDE, you see that I'm using VS Code. VS Code has Go tools, not built right in, but really, really easily downloadable. And so you see, here's me stumbling through writing my Go code. See, I make a main. Sorry, I'm throwing the microphone around. Let's see, fumped printf. You see I get help for it. And then what's really great is I have a thing that will just call in. If I call code, it'll automatically write the import for me. And that's called Go imports, which is sort of a superset of Go fumped. And you'll notice that I put all those extra lines and I saved it. It automatically wrote back. So that is that. All right. So that's it for kind of talking through the language. Now I want to talk about some use cases. I want to talk about when does it make sense, not necessarily switch, but to sub in Go for something. So I'm going to take my first task here, which is I'm going to get articles from a WordPress MySQL instance. I'm going to flatten them into straight HTML files. I don't want to store it in WordPress anymore, maybe, and I'm going to write it to disk. All right. So in all of these examples I'm going to go through, I didn't necessarily write the best PHP or Go code I could. I wrote a straightforward brute force algorithm, unless I make a notice that I did, like I'll call them out in a couple places. But I basically just straightforward got done the task. It happened in a reasonable amount of time, so I didn't overly optimize either end of this. So when I wrote to disk, so I wrote the same algorithm in both languages. I tried to do it 10 times, and you'll see that PHP happened in 573 milliseconds, and Go happened in 557 milliseconds. And if I increase the time to 100, you'll see that the PHP was actually faster than the Go. Why? Because if you repeat this a whole bunch of times, they'll go back and forth, one will win and one will lose, because the processing and the memory and all that, like that's not the real stumbling block here. The real stumbling block here is I/O, and I/O is expensive. Like doesn't matter what language you're using, I/O is going to be expensive. Now, that was my first attempt, but I was like, come on, you're talking about Go. You should make it outperform, right? Like you should have a point here. So I cheated, and I wrote, the first time I did it sequentially. So basically, I just looped through, and every time I had a function that wrote the outputs. For my second attempt, I used concurrency. So just exactly what I did before. I waited till they were all done. I'm sorry, I fanned out to as many processes as I needed and waited till they were all done and finished the Go code. When I did that, you'll see that I got it, so the PHP took 4.6 seconds and the Go took 2.8 seconds. Is this really compelling to like switch? Probably not, right? If I'm doing this, if I have to do this millions and millions of times, well, maybe, because that is, a 60-something% reduction. But those numbers will go back and forth, and so I mean, honestly, in this particular use case, surprise, like you shouldn't necessarily switch, right? It doesn't really buy you anything. So for my next one, I got rid of I/O, right? And I just did a memory and processor intensive operation. So get password from a randomly generated list. Okay, so I have a list of passwords that I'm going to scroll through. I'm going to test if that password conforms to dictionary, like rules. So uppercase, lowercase, has numeric, has special characters. But it also includes the dictionary check. Does this password contain any word in the dictionary? In the dictionary that I have. So for my first method, the best way to do this, like algorithmically, or I'm sure there are better ways to do it, but the best way I have found is to break up the word into all the valid parts. And in this particular case, the minimum length of the password was 4 characters, so I didn't have to look for words smaller than 4. I'm sorry, the minimum length of a dictionary word was 4 characters, so I didn't have to look for words that were shorter than 4 characters. I break it up in all the constituent things that it could possibly be, and I spin through looking through that in the dictionary. And then I can do a whole bunch of things like, well, if it's not the same length, it's not the same thing. If it doesn't start with the same letter, it's not the same. And I can speed up that algorithm pretty quickly to the point where if we do it 10 times in PHP, 141 milliseconds, and 10 times in Go is 77 milliseconds. If I up the trials to 1,000, I'm seeing, 200 to 91. And then if I up the trials to, 100,000? 100,000. PHP takes 7 seconds, and Go can happen under a second. So it's about 7 times faster. I had to double check this result. I want to make, because it doesn't scale linearly. It just doesn't. Go over time, Go is able to just outperform PHP on this particular task. Now that's with the optimal algorithm. If for some reason I needed to just do brute force and just check every single word is in this dictionary, because I don't know, I don't trust the other algorithm or something, then we get a different result. PHP 900 milliseconds to 94 for 10. When we get to 1,000, PHP takes 96 seconds, whereas Go happens in 1.8 seconds, or 45 times faster. So for this particular use case of doing something that's just memory and processor intensive, doesn't have any I/O, Go can significantly outperform PHP. Now, if you're not having a problem with a part of your site, with a part of your code base, don't switch to Go. But if you have a performance problem, like one part of your PHP, and you haven't been able to solve it with an algorithm, it might make sense in one case to drop down just for that one operation to Go, write an executable, and do it that way. You can also do, obviously with PHP, you can also go drop down to C. I don't know, I like writing Go better than C, which is why I bring it up. All right, my final task is more of a systems problem than a coding problem. So I wrote an app, and I'll show off the app just because it's fun. So we're doing a big event for us. We're showing off a technology called Kubernetes and container engine. You guys, anybody here familiar with Kubernetes? I'm talking about it tomorrow, so if you want to know more about it, you can. Long story short, I wanted to show off what Kubernetes can do. And one of the things Kubernetes can do is I can run containers on it, and if the containers go down, it can bring them back right away. So I can say, always run 12 containers, and Kubernetes is going to keep 12 containers running. So we're doing an event. We wanted to show this off, so I wrote a game, Whack-a-Pod. So what I'm going to do here is I'm going to fire up a Kubernetes cluster, and these are all my containers, and I'm actually going to go through and kill them. Right? So, I got sound too. So you see Kubernetes kind of brings them up. Now there are 3, I knocked down the service. Cool. I got the bomb. So it's kind of simple and silly, but there are 3 containers going on here. There's the UI, which is served up by one container. There's the color service. You see the color is constantly changing? That's the service that we're trying to take down, and these pods are running it. And then there's an admin service that takes the commands, delete pods. So when I go to kill one of these, there's an admin process that's holding on to that. All right, so that's my app. I first wrote it in PHP because I needed to get it done, right? So I wrote it in about a week, less than a week actually 2 days, as a proof of concept, and it ended up kind of going forward and being a version of this, not this version, because they didn't like the whimsical mole stuff. So we changed it to be corporate and ugly, but whatever. That's another story. But we used this. We used this PHP code. We used it to demonstrate at our big corporate event with 10,000 people there. Cool. But I got this request. Can we move this to run not on your container? Like, I don't care how big any of the containers are because I don't pay for computing, right? Because I work for Google and Google pays for it. But people were like, hey, it would be great, but we'd like the containers to be smaller. We want it to run this thing called Minikube that'll run on a laptop. And so we need much smaller containers. All right, so that's the task. So when I wrote it in PHP, so we host on Kubernetes, but have the smallest Docker containers possible. So when I wrote it on the first pass, I did the API, which is the random color generator. I did that in PHP, and the Docker container I used, which was Google App Engine PHP latest. That's a version of, it's a container of PHP that we run. It's pretty lightweight, not as lightweight as it possibly could be, because it has PHP, Nginx, and then the Google Cloud SDK, so it ends up being 171 megabytes with the code added to it. You see that over there. That's not outrageously big, but it's also not optimized. The admin, which is just a Kubernetes, is a proxy to the Kubernetes API that lives on the cluster. That was also written in PHP. That was also the same image, and that was 171 megabytes. And then the game, which is the UI for the app, was just HTML, JavaScript, CSS. I did with the same image, and you'll see that's like 10 megs more because there's images and stuff in it. So this whole game clocked in at 523 megs of stuff, like half a gig that I'm pushing around to various clusters and containers to use. I could do this better. I could do this faster. So one of the tricks you find out when you start using Docker and you start using Kubernetes is you can use minimal containers. And the minimalist container that you can use, is that a real word, minimalist? Yeah, it is, but I'm thinking I'm using it wrong. All right. The smallest container that you could possibly start with is something called Scratch, right? Which is nothing. Like, there's nothing going on in it. Like, you try to telnet, you try to SSH into it, and it'll do nothing, right? But with Go, I can write an executable that contains everything I have on it. And put it in. And so this is a kind of common thing you do. You take Go, you build an executable, you host it on Scratch, and it just handles everything it has to handle. And so you can make very, very small Docker containers with this. How small? Well, my API I shrunk down to 2 megabytes. The admin I shrunk down to 2 megabytes. And then for game, I didn't use Golang and Scratch. It was HTML, JavaScript, CSS. So I just switched to Nginx because I wanted there to be wanted to use Nginx and not have to write my own version. So I was able to shave almost 90% of the size of these around by switching to this. Now, this wasn't prompted by a developer need. This wasn't prompted by, Go could do something PHP couldn't from a developer, well, sort of, right? building an executable out of PHP code, like you can't do that, at least not natively, as far as I know. But you can kind of do this with it. So does it actually matter in this case? Yes, it did matter. Being able to shrink it down made me be able to use it on much smaller installs of Kubernetes and allows me to use this demo in more places. So Go weirdness, there's some things that bug new Gophers. One, there's no concept of exception. You'll see that throughout the entire code base, whenever I deal with an error, I do this. If error does not equal nil, return nil. And in fact, this is the joke that this is a Go programmer's keyboard, right? Because they need this button, because they write this all the time. People get frustrated about it. You'll see why I don't like error handling in Go right there. This will be shared, so if you want to call these links, you don't have to go to them now. So all I can say is, yeah, it's frustrating when you first come to it, but you get used to it. And then you end up, like for me, who is somewhat sloppily inclined to write code, having to handle all your errors right away personally has made me better at programming. So, but you get used to it. No generics. Some people, this drives them nuts. Golang does not have like a generic class like you can have in Java. Maybe arrays, slices, and maps will work. Maybe an interface will work for what you need. Maybe using Vardic functions will use, and maybe Go isn't for you. If you really, really need generics, Go isn't going to be for you. Right? GoPath is confusing. Yes, it is. So you have this concept in Go called GoPath. All your Go projects happen in a workspace, and a workspace has source, bin, package. So you take all of your code, typically, and put it in source. So in my case, I have a folder, GitHub / my username, tbrian / a project name. And all of it happens there. It gets difficult. Like, what if you want to include your Go program in another place on your file system? Then you start doing weird stuff with symbolic links and stuff. But Go is going to look for all of your other code, all of your binaries in this space. So typically, you write a GoPath environment variable that points to your Go folder. There's no way around this. It is annoying and hard to deal with, and does cause some impedance when you first move over to Go. Just be aware of it. Dependency management. Dependency management can get a little frustrating. We don't have something like Composer in Go just yet. There is this thing called DEP, which is maturing soon. It should be out within the next couple of months. It's in beta now or alpha now. So in the bleeding edge versions of Go, you can get to it. But right now, the problem is not easily solved. So some conclusions, real quick. I want to make it, like I said, very clear. Use Go for problems where you're having pain in PHP, dealing with all the things you need to handle. But I get very worried when I'm the Google guy that people just sort of shrink things down. And so that Google guy said, use Go for all the things, right? And stop using PHP. That's not what I'm saying, right? There are times where Go can give you really, really good productivity enhancements and performance enhancements. So if that's the case, use it. If not, don't. Also, when you go to search for stuff, you're going to want to search for Golang instead of just Go. Otherwise, you'll find a lot of confusing results. They solved that problem relatively early with the language. They refer to it often as Golang in articles and whatnot. And then finally, I stole images. Thank you guys very much. If you want to get in touch with me after this talk, Twitter is probably the best way. If you want this prezzo, it is available. It'll be available through the conference, but also if you want to get to it directly, bit.ly tbrian-go for PHP. With that, I'll say thank you guys very much, and thank you.